Morning everybody, here we are ready for our last day on area of a triangle before we do some problem solving tomorrow. So let's start with our 4-minute warm-up. So today we're going to go all the way back and have a look at percentages, see what you can remember. Now my one tip before you pause the video and have a go at this is to remember, if you're calculating the percentage, always find 10% first. Okay, so remember to find 10%, divide by 10, and then you can find the rest. Pause the video and then come back for some answers. Okay, so let's have a look at how we've calculated these then. So for number 1, when we're calculating 20% of 120, what we need to do here, like I said at the beginning, is to think about what is 10% of 120. So 10% is 120 divided by 10, which would give us an answer of 12. So to find 20%, we need to multiply that by 2 to get an answer of 24. Now for 60% of 90, again, I'm going to find 10% of 90 first. Now 10% of 90, I divide 90 by 10, which gives me an answer of 9. So 60% times it by 6 gives me an answer of 54. Now for 25% of 280, I work this out in a slightly different way, because I know that 25% is the same as 1/4. So really all I did was think, well, what's 280 divided by 4? Which gave me an answer of 70, because that's 1/4 or 25% of 280. And finally then, 6% of 400. Now you could use 10% here, but actually we could go another step and think, well, what is 1% of 400? So to find 1%, we actually divide by 100. So 1% of 400 would give us an answer of 4. So 6%, I times that by 6 to give us an answer of 24. Hope you've remembered how to do all of that. Okay, now for today then, we're doing the final section on calculating area of a triangle. Now we need to today be able to identify the base and the height of a triangle. This part's really important. We need to decide which lines are perpendicular. We're going to talk a little bit more about that in a minute. And then it will mean that you can calculate the area of any triangle. All right, so for our Discover, we've got Mo and Lexi, and they've been drawing some triangles to go on some signs to label the library and the reading area. Now, our first question is, what is the area of the triangle on Lexi's sign? Now, here it is a little bit larger, and it's got the measurements on it. Now, in order to calculate the area of this triangle, there are 2 ways we can do it. Now, when Mo did this initially, he thought, right, what I'm going to do is I'm going to think, well, I can see that this triangle is still part of a rectangle. What I'm going to do is I'm going to calculate the area of the yellow triangle first, and then the area of the red triangle, and then I'm going to add them together. Now, I can do that because I've got the squares on this paper. And I know that this is going to be possible because I've got a right angle in there. So that's how our triangles have been looking. We've been looking at right angled triangles because that's very obviously given us the height and it's given us the base. We've times those together and then halved them. So let's have a look here. So we can see that along the base of the yellow triangle, I'm counting the centimetre squares, there are 9 centimetres across the bottom, and going up the side, 1, 2, 3, 4, 5, 6 going up. So that means it's 9 times by 6. So 9 sixes are 54 centimetres squared, but that's obviously for the whole rectangle. That would be if this yellow had made a rectangle like this. So remember from yesterday, we now need to think, well, it's only the triangle, so I've got to divide that 54 by 2. I've got to halve it. Now I'm going to break that down a bit. So I think, well, half of 50 is 25, half of 4 is 2. So that means half of 54 must be 27 centimetres squared. So that's told me the area of the yellow triangle. So let's do the same for the red. So I can see that it's got 1, 2, 3, 4, 5 centimetres along the base, and it's going to be the same, look, 6 going up. So let's do that over here. So it's 5 times by 6. So 5 sixes are 30 centimetres squared. But again, that would give us the area of the whole rectangle. And again, you can check it, can't you, if you want to make sure that you've got that right, because look, this is like rows, isn't it, here of 5. So that would be 5, 10, 15, 20, 25, 30 centimetres. Yes, but we only want half of that. So now we've got to think, well, to get the triangle, we've got to do 30 divided by 2. And half of 30 is 15 centimetres squared. So that gives us the area of the red triangle. And then our final step is that we would have to do 27 and add the 15 to it. So 7 add 5 gives us 2. 2 add 1 gives us 4. So the final area of that triangle is 42 centimetres squared. Now, that's quite a lengthy way to calculate that. And obviously, it relies on us having those centimetres squared in there so we can work out the base and the height for each one. Now, here is another way of thinking about it. Okay, so this is Mo's rectangle. Okay, now the difference here is that Mo's rectangle hasn't got those centimetres squared. So we might think, well, actually, look, I'm going to make them into 2 right angles like that. But now I don't know the lengths of the base, do I? So actually, how am I going to do it? Well, you can see here that even though on this first diagram, this here is the height of the triangle, isn't it? The 30 centimetres. That is the height. Now, if we've got the height of the triangle, that means it's the same as this height, isn't it? All right, just because it's drawn over here, it doesn't make any difference. So we know that the height is 30 centimetres and the base is 40 centimetres. So like we've done previously with our right angle triangles, if we multiply the base, which was here, 40 centimetres, by the height, I'm going to put a B for the base and the H for the height. I'm going to multiply them together, and that gives us 1,200 centimetres squared. Now that would be for this whole rectangle, so all the way around here. So even though it's a bit harder to see where that's split in half, we can still halve it, divide it by 2 for step 2, to give us an answer of 600 centimetres squared. And that will give us the area of the triangle. So what we can take from this is, for any triangle, we can say that to find the area, we need to have the base of the triangle, we need to have the height, we multiply those together, and then we can divide them by 2 to get the area of that triangle. This part here, though, is the most important sentence I want you to take away from today's lesson, is that the height is always perpendicular to the base. Now, I know some of you might be thinking, oh, I can't remember what perpendicular means. Well, perpendicular, I want you to think of 2 lines meeting, okay? So here's one line and here's another line. Now, when 2 lines meet in a perpendicular manner, they're meeting to make a right angle. So let's have a look at this diagram here. Can you see we've got a triangle here where we've got the base and then we've got the height. Can you see this little red square that's been drawn in just here? That shows that where this dotted line here, this height line, meets the baseline, it meets at a 90-degree or a right angle. And that means that those 2 lines are perpendicular. Now, those 2 lines which are perpendicular will tell you that one of those is the base and one of those is the height. Often we're given, say, the length of this part of the triangle. And sometimes children get confused and multiply that by the base. But that won't work because that isn't the height and it's not meeting the base at a perpendicular at a right angle. So that's the key for today. The work in the books is all about this, where you've got to spot, well, which one is the height line? And you're looking to see which one is meeting at a right angle. Let's have a go at some together. So here we are, we've got to calculate the area of this triangle. Now we can see which is our baseline. This one here, look at the line across the bottom. Here is our base, which is 8 centimetres. So we can put that in the box. The height is just here, isn't it? Because that's definitely, look, it's got that right angle there meeting the baseline. So that's 2 centimetres. So 8 times by 2 is 16. And then this part, don't forget this step, we've got to divide it by 2. We can because otherwise we're finding the area of a rectangle rather than a triangle. So we've got to halve 16, which gives us an answer of 8 centimetres squared. Okay, let's try the next one. So here you can see the base is 6 centimetres squared, okay, and the height is 3 centimetres squared, because again, look, those lines, they're meeting with a right angle, okay. If we had said that this was 3 centimetres here, okay, that wouldn't be our height, because that's not meeting the base at a right angle. So 6 times 3 is 18. So actually what might be helpful is if when you've calculated that bit, that's 18 centimetres. That would give the area of the whole rectangle. So we've got to halve it. So half of 18 is 9 centimetres squared. Now, I want you to pause the video and have a go at this one. And I want you to think really carefully which is the base and which is the height. Look out for which line is meeting the base at a right angle, which is a perpendicular line. That's going to give it away. Pause the video, have a go, come back to see if your answer is correct. All right, so the base is here, 11 centimetres. Now, which of these two is the height? Is it 6 centimetres? That's the longest one, so often people think, well, that must be the height, because that's the longest other length that I've got there. But no, look, this bit here is the line that's meeting the other line at a right angle. So the height must be 4 centimetres. So to calculate the area, we're going to do 11 times 4, which gives us an answer of 44. And then we've got to divide that by 2. So 44 divided by 2 gives us an answer of 22 centimetres squared. All right, now this one here, this is a little bit like some of the questions you're going to be looking at today, and you've got to figure out the mistakes that have been made. Now, Max has calculated the area of this triangle, and he thinks the area is 18 centimetres squared. Now, what mistake has Max made? What should he have done instead? So we've got to think, well, how has he calculated the area of 18? Now, he's either going to have thought, right, well, here's my base. Let's go with this one here. So if he's thought 6 centimetres is his base, okay, and then he's got to find a height line. Now, he's maybe thought, well, look, 6 centimetres, that's joining onto this baseline here. So that must be my height. 6 centimetres times 6 centimetres, well, that gives us 36 centimetres squared. But remember, that would give us the area of a rectangle. So then we've got to divide that by 2, and that would give us 18 centimetres squared. So that's obviously what Max has done. Now, is he correct? What do you think? I think he's not correct, because I'm looking at where this 6 centimetre line meets this 6 centimetre line here, and actually that's bigger than a right angle, isn't it? It hasn't met to meet and make two perpendicular lines there. It's got a bigger angle, it's larger than 90 degrees. So the height, if we look over here, look, even though this is like a dotted line, isn't it, where the 5 centimetres is, can you see this one here? This is not actually part of the triangle, but it's meeting that 6 centimetre line with a right angle. Can you see? Therefore, 5 centimetres is our height. So this one here is wrong. We needed to do 6 centimetres for our base and times it by 5 centimetres for our height, which would give us an answer of 30 centimetres squared. Now, because it's the triangle, we've then got to half that. So half of 30 centimetres squared is 15 centimetres squared, and that is the correct area of our triangle. Now, you will see in your books today, when you're calculating the area of some of these triangles, I'm just going to page 1, you'll see that the first question, it's quite obvious which is the base and the height. Now, when you get onto the second page, you've got to decide which one is the height. There's sometimes 2 to choose from. Always look, you are looking for those lines that are meeting at a right angle to make them perpendicular, because then one of them will be the height and one of them will be the base. Okay, all right, so Power Maths today, this is area of a triangle part 3. You're working on pages 135 to 137. get stuck at all, or are you thinking, oh, I'm still not quite sure, please send me a message and I'll do my very best to give you some help. All right, have a great day and I'll see you tomorrow. Bye-bye.